on this warm-up problem. So take a minute if you haven't already tried that problem as a warm-up. When you're done, put a thumbs up in the chat, or you can just send a message, or a thumbs up as a reaction, sorry. All right, so the mistake was yes, secant should have been 1 over cosine of theta. Very good. Yes, Landon. So that's just a reminder of trig identity. Just want to make sure we don't forget old concepts as we kind of talk about a new unit, which is conic sections. So that leads us to our lesson for today, which is lesson number 31. This is ellipsis part 1. We're in our unit on conic sections. If you remember last class, we did what is a conic section? How does it relate to a double nap cone and a plane? What are the different intersections that you can have a plane intersect a double nap cone in order to create a different conic sections? And we talked about going to standard form of a circle by completing the square. So today we're talking about ellipses. This is going to be intro lesson part 1. We have 2 lessons on this. This lesson is going to be about how just kind of mainly vocabulary for now, and then the general equation. And then next class tomorrow we'll do more of how to write the equation, giving different features about it. Okay, so that's what today's lesson will be on. So here's where we're at for this week. Today's Wednesday, ellipsis part 1, and then tomorrow we'll do ellipsis part 2. It's just going to be 2 lessons on the ellipses, and then Friday Zoom office hours if you have any questions on anything of this week. Okay. So as always, we start by saying our 4 goals. So we will learn math, build character, never give up, and ask why. All right, so let's jump into it. And again, make sure to pause me if you have any questions as we go through, if I'm ever going too fast. So my first question is, if I asked you to draw a circle as good as you could without tracing a circular object, what would be the way that you would go about doing that most effectively? If I asked you to draw a circle, anyone can unmute themselves and share. So if I asked you to draw a circle, but you couldn't trace an object, how would you go about doing that most effectively and accurately?
Use a compass.
Use a compass. Okay, so you could use a compass. So the compass is all related to what point when you're drawing a circle?
The center point.
The center. So for a circle, if you were to use a compass, you would go around the center, right? And every point will be equal distance from the center, and the compass kind of helps you to draw that accurately, right? If I asked you to draw an ellipse, it would be a little bit more difficult. If just to make sure we know what an ellipse is, ellipse looks similar to a circle, but it's kind of a little bit more stretched out, right? That's an ellipse. So if I asked you to draw an ellipse freehand without drawing a figure, it would be a little bit more difficult to do, right? Because everything is not equal distance from the center. It's different distances depending on where in the ellipse you're going to. So in order to draw an ellipse accurately, one of the ways in which you can do that is use 2 points called foci, okay? This is introducing our first vocabulary. So this right here is called a focus, and this is called a focus. Together in plural, it will be called foci. So every ellipse has 2 focuses, which plural you would say 2 foci, that are a part of the ellipse, that you could kind of say it's similar to the center of the circle with respect to the fact that every point in the ellipse on the outside relates to those 2 focuses. So let's say you wanted to draw an ellipse. Then one of the ways in which you can do that is, once you've determined where the 2 foci are, which we'll talk about what those are in a second here, you could take a rubber band and you could put a pencil. The rubber band will be connected to those 2 focuses, and you could just go around. And when you go around, pulling the rubber band around, it would create an ellipse. okay? The reason for that is because when you think about a circle, it's not a great circle, but the circle, and the center, if this distance is 2, every distance from the center to the edge is equal, right? That's the radius. For an ellipse, and if we were in class, I would have you measure this to kind of see, but for an ellipse, if you take this first focus here, and let's just say you pick a random point on the ellipse, like let's say I pick this point right here, and you measured the distance from here to here. We'll call that D1 or distance 1. And then you measure the distance from the second focus to that same point. We'll call that D2. Okay. So the distance from one focus to that point, I just picked that random at the edge of the ellipse, and then another focus to the edge of that ellipse. And then let's just say I pick another random point. Like let's just say I pick this point right here. Okay. And I do the same thing. I measure the distance from this focus to here, and I call that D3. And I measure the distance from this focus to here, and I call that D4. The relationship between those distances, no matter what point we pick on the ellipse, is that D1 plus D2 will be equal to D3 plus D4. That's how you would that's a kind of baseline of how an ellipse is connected to those two foci. Okay, so no matter what, anywhere on the circle that you pick, the distance from the two foci to that point is equivalent to any other point's distance. Because if you think about it with the context of this rubber band, the distance of this rubber band added together is not changing no matter where around the ellipse that you go. So that is kind of the relationship between an ellipse and foci. Any questions so far? Okay, cool. I think that's pretty cool, pretty neat. All right, so let's talk vocabulary, okay, of an ellipse. There's quite a bit of vocabulary words here. So first of all, this one would be called a horizontal ellipse. For obvious reasons, because it's kind of more wide horizontally. This one would be called a vertical ellipse because it's more stretched vertically. So we can have a horizontal ellipse and a vertical ellipse, okay? We're not going to have diagonal ellipses, okay? Because of the way the equation works out. So it'll be horizontal or vertical. Now there's several kind of vocabularies here. So the major axis is going to be if it's horizontal, it's going to have a horizontal major axis, which is basically the distance from one end of the ellipse to the other end of the ellipse, and it's the longest axis that cuts it. It has to cut in half through the center. So this is not a major axis right here. It has to cut in half through the center. So this whole length is called the major axis. Think axis of symmetry. Axis of symmetry, when you cut a parabola in half, axis is kind of cutting it in half. But major means big, so that's the bigger one. Minor, meaning small, is basically the smaller kind of cut in half that you can do with that axis. So this from here to here is the minor axis. Okay, so major axis is the longest length or axis that you cut it in half. Minor axis is the shortest, but both of them have to pass through the center. If it is a horizontal ellipse, then the major axis will be horizontal. If it is a vertical ellipse, then the major axis will be vertical, because then that will be longer axis, and the minor axis would be horizontal. Okay. Then we have the A. So the A is basically the distance, or it's half of the major axis. So it is the distance from one end of the major axis to the center. That is the A. Okay. A is always going to be half of the major axis. The B is half of the minor axis. So it's the distance from the edge to the center on that shorter half. Okay. So if we're looking at the vertical ellipse, and this is now the major axis, now your A would be from here to here because it's half the distance of the major axis. And your B is half of the minor axis. So your B is going to be this right here. And these are equivalent. This is B as well. The distances are the same. Any questions thus far? This is just vocabulary. So we have our major axis, and then we have our center. Y'all know the center is the middle of the ellipse. I meant to mention that. And still represented by H and K, similar to a circle. It's H and K. We're not going to have a radius here because it's not equal distance from the center. There's an A and there's a B, two different distances that we will represent it with. Okay, let me ask a question then. If you think about this, which one will always be bigger? It's just important to note. Will A always be bigger, or will B always be bigger in an ellipse? Will A always be bigger, or will B always be bigger? A quick check for understanding. I want you to just take 30 seconds and just, based on this ellipse that you have here graphed, you're going to tell me what the major axis length is, the center, the measure of A, the measure of B, and the minor axis length. Okay, so I'll give you about 30 seconds to get that on your own, and then just ask y'all at random. Okay. All right. So let's see what we got. Let's start with Jair. Jair, tell us what you got for A, the major axis length.
Is it 6?
Is that a question or a statement? Yeah, it's six. You're good. From here to here, yeah, that's 6. Jocelyn, what we got for the center? Jocelyn, what do we have for the center? Okay, see your message in the chat. -1, comma 2. Yeah, that's our center. The measure of A, Kevin? It's the measure of A.
3.
3. Okay, good. Because it is half of the major axis, you could divide this by 2, or you could just look at it visually. Measure of B, Brianna?
2.
2. Okay, good. That's right here, half of the minor axis. Claudia, the minor axis length. Claudia?
Is it 4?
Yeah, 4, yeah. Yeah, y'all ask me questions or be confident, you got it. 4, yes. So that is just some vocabulary that you would need to know there, okay? So now that we got the vocabulary down, let's kind of apply that in the context of the graphs like you just did, and then we're gonna do equations, okay? So this is kind of very similar. So we have this, this ellipse. It is horizontal. We'll do this one together. Horizontal. The major axis is the longest axis, which in this case is all the way across here. So 1, 2, 3, 4, 5, 6. The minor axis is the smaller axis, which would be 2 here. Vertices, so that's a new vocabulary word we need to know as well. Vertices are, think like vertex. Usually a vertex on a parabola lies at the end of the axis of symmetry, or at the end of the parabola, it cuts through the axis of symmetry, or the axis of symmetry cuts through it, sorry. So a vertice is at the edge of the um, major axis, what is the point that lies on the ellipse? So this right here is a vertex, and this right here is a vertex. Together, plural, they are called vertices. So vertices are at the ends of the major axis, so the bigger axis. So those would just be ordered pairs. So the vertices are 5, 0 and negative 1, 0. Okay. Co-vertices would be at the ends of the minor axis. So this 2, sorry, let me label this as covert. So this is a covertex. And this is a covertex. So that would be 2, 0 and 2, 2. So covertices are at the ends of the minor axis. Vertices are at the end of the major axis. Okay. The center is just the center in the middle. So that is 2, 1 in this case. And the A, again, remember, is half of the major axis. So you can look at the graph, or you could just do half of this major axis, which would be 3. B, half of the minor axis, which would be 1. Okay. All right. Yeah, I'll go ahead and try the one on the right. I'll give you some time on that one. This is where I was telling y'all that you're going to need a lot of graph paper if you were able to print out some, or you were able to just kind of create your own, because these graphs aren't always given to you. I printed them on your paper, but like usually any like assessment or things like that, you wouldn't have this graph. You would have the chart paper, that they give you during ACPs that like don't have the X and Y axis. And so just so you can kind of get used to that, or you would have to draw your own, like just kind of sketch like that. So just to get used to that, make sure you have some graph paper, because a lot of the practice problems you would just need graph paper to just kind of draw a sketch. Okay, so give you some time to try that. Okay, I don't have everyone, but we'll go ahead and talk about it just in case if you were stuck. Jimena, can you continue us off from here? So I drew the vertices here, and then where did you go from there?
I did the minor axis of 4 units, so that means I would go. That means it's smaller than the distance from the uh vertices.
Okay, so this is a major.
So yes. So I went right 2 and left 2 from where the line would be the major axis.
Okay, so here's the major axis, but like, how did you know where to start? Like, where to draw?
Oh, because of the center.
Okay, so here's the center, and then okay, left 2 and right 2. Okay, good. So then, okay, so these are the ends now. Okay, so that's important to know. It didn't give you the center, but if you have the vertices, then you know where the center is, because it has to be in the middle of the 2, right? Okay, so then that's our ellipse. Very good. All right, so Maria, help us out with some of this vocabulary down here. So is it horizontal or vertical?
Vertical.
And what's the center?
Negative 4,4.
Okay. Alexander, what we get for the major axis length?
6.
Okay, good. 6. That's from here to here, vertice to vertice. Co-vertices, let's go, Kelly.
Negative 6, 4 and negative 2, 4.
Okay, good. These two, that's on the sides of the minor axis. And the A, let's go, Hugo. Oh, he's not on. Oh, he is in the chat. Yeah. Okay, I see it in the group 3. Yes. And the B, Carla. 2. Very good. All right, so that's just kind of some of the features of the graph. All right, so let's talk equation. That's the last piece here. and then we'll do more tomorrow, okay? So ellipse, if we remember from we talked about the formula sheet, which you will have to refer to, so I'll make sure you have that out in the future. I'm talking about these equations here. We're going to focus, we're not going to talk about this quite yet. We'll talk about that later. We're just going to talk about the equation here. So if you notice, there are two different equations that you could use for an ellipse, okay? What are some things that you notice that are like similar about them, or something that you notice that's different about the two equations to take note of? So we're just focusing, let me zoom in. So just there's two equations for an ellipse. What do you notice that's similar about them, or what do you notice that is different about these two equations? Or just in general, what you notice?
In the first equation, x minus h is over a squared, and then in the second equation, x minus h is over b squared.
Okay, so there's a movement of the x minus h. So Hugo says that in the chat as well. The tops are flipped. So these are in different order. What else do you see about it? I like that color. That's a nice color. Sorry. What else do you notice about it? Like anything you see. Like I see, for example, there's an H and a K. That should tell me what? The center, right? So what else do you see that we've talked about maybe?
Like the standard form for a circle.
Okay, good. So similar to circle, you have the x minus, because the circle was this, right? X minus h squared and then y minus k squared, and then equal the radius squared, and it kind of looks similar to that. You have the x minus h squared, the y minus k squared, but then it says equals 1, and that kind of has to do with the fact that what we talked about earlier, how the distances, when you add them, remain constant, so there's a constant there. The proof of this formula is a little bit long, so I'm not going to show it to you on this video, but it is in the textbook if you're interested in the proof of that equation. Okay, we also should see an A and a B, right? We talked about A and B, so what this means is if we have the A and the B, and we have the H and the K, that's enough information to write the equation of an ellipse. All you need is the A, the B, the H, and the K. So the center and the A and the B, okay? And we'll talk about the differences between these two here in a second, but just want to discuss those, all right? So let's look at the differences. So first thing to note is that the equation, which I believe was on the left in the formula sheet, this equation is for a horizontal ellipse, okay? So when wait, hold on, let me rewind it back real quick. Let me see something. Yeah, so this is slightly flipped. So like in the way I have it here, the order is different. Like the y is first, if you see here, the y is first for an ellipse. So you can write it either way. You can write it like, because there's a plus sign, so the order doesn't matter, right? You can write this in front, or you can write the y in front. Either way is fine, okay? So just something to note. Just to make sure y'all understood what I said, meaning like in your formula sheet, this is written as y minus k squared over a squared plus x minus h squared over b squared, right? So it's just these are switched order, but it doesn't matter either way because it's addition. 3 plus 4 is the same thing as 4 plus 3, okay? All right, so the equation for a horizontal ellipse, the basic concept to know is that in the horizontal ellipse, the a squared is under the x. In the vertical ellipse, the a squared is under the y. That's the biggest difference and really the only difference between the two. So here's how I remember it. When I think about horizontal, and I think about this axis is the horizontal is the x, right? And so a horizontal ellipse is going to have a, excuse me. All right. Sorry. Yeah, I know when I sneeze, I never sneeze once. It's really weird. Okay. So for a horizontal ellipse, the A is always under the X. And so I remember that as horizontal axis is the X axis. So A is under X. Vertical is the Y axis. So then I think if it's vertical, the A has to be under the Y. That's what helps me to remember it. If you have another way to remember, you can use that. But that's what I found to be helpful for me. All right, so that's just a way to think about it. Okay, so horizontal ellipse, A under the X. Vertical ellipse, A under the Y. Okay, so let's so all we really need again, like I said, is the center, the A and the B. So the center is 2, 1. The A is 3, and the B is 1. So if you have that information, then you can write the equation. And this is a horizontal one, so the A is under the X. So in writing the equation, start with this part. It'll be X minus, and the H is the X of the center, so X minus 2 squared over the A here is 3, but we would be squaring that. And there'll be Y minus K, which is the Y of the vertex or of the center. So Y minus 1. And then over B, which is 1 squared. Okay, equals 1. It's important that you put equals 1 because otherwise it's not an equation, it's an expression. And when you simplify that, you can go ahead, you can change this 3 squared to 9 and this 1 squared to 1. And so this is the equation of the horizontal ellipse. So that's it. All you need is the A, the B, and the center, and then you have it. And just so you can know for purposes, just so you can see how you would graph it. And I know many of you may not have the calculator, but you can, if you go to delete and you go to relation, and then, can someone read it to me so I don't flip back and forth what the equation was? It was X minus,
minus 2 squared
thank you,
over 9 plus y minus 1 squared over 1 equals 1.
Okay, so you can, if you go delete and you go relation, you can graph it and you can see there. And that's the way you can also check your work, but you can see there that that's the same ellipse that we had. You also could, I don't know if you can do it on here. Menu, I don't know where the menu is on here. This is supposed to be in Inspire, but it's, slightly different. But yeah, I don't know. Usually, you go to menu and then you have the options. There's a menu and then graph entry ellipse, but you can just do relation. Okay, so horizontal ellipse always starts with A on the first denominator below X. That's just how I remember it. Don't worry about this part. I realize that's kind of wordy and it's kind of confusing. It's just explaining the difference between the horizontal and vertical ellipse. Okay, let's look at vertical. So for vertical ellipse, like I said, the A is under the Y, and it doesn't matter the order in which you put this. So similar, you just need the A and the B. So the center, -4, 4. The A is, what's that, 1, 2, 3. The B is 2. Zane is trying to come in. I don't know if y'all can see it. So the A is 3. Come on, buddy. The B is 2. Sorry. So the equation would be x. Now be careful here. It's h. So you would put, and it's minus h. So you would put, you have the minus and then you have the negative. So it'd be minus -4. So it'd be +4. And then over b squared, because it's a vertical ellipse, so 2 squared, so that'd be 4, plus y minus k is 4. That'd be squared, over a squared, which would be 3 squared, so that would be 9, and that equals 1. So that's the equation of the vertical ellipse. All right. Any questions? No? Okay. So that's the basics of ellipse. So we got kind of what the vocabulary is of them and the equations of them. Next class we'll do a little bit more with that. Here's a few just examples of what we just talked about, just to make sure we're good with the relationship between the equations. So I'll just do the first one with you, just to make sure we feel confident. So, so if we have this equation and we want to graph it without the calculator, first thing we need to identify is whether it is vertical or whether it is horizontal. So let's, Certainty, let's hear from you. Is that a vertical ellipse or is that a horizontal ellipse? Certainty, is that a vertical ellipse or a horizontal ellipse?
A horizontal.
And how do you know that?
Because the 16 is bigger than the 9.
Yes, very good. So it's a horizontal, because you remember the A is the bigger number, and A squared, that's the bigger number, 16. And so therefore our A, you got to be careful here, that A is not 16. A is whatever squared gave you 16 because it's already simplified, right? So you can do the square root of 16 if you want, and that will give you 4. Or you could just think what squared is 16. Okay, very good. So then the B would be what their, Natalia, what would the B be?
3.
Yeah, 3, because 3 squared is what gives you 9. So the B is 3, yeah. And the center is, yeah, you have to be careful with the center as well, because you have to remember the formula is x minus h squared, and it's y minus k squared. So for the h, it's 3, not -3, because the minus is a part of the formula. For the k, since it's minus k, and it became a positive 1, that means that it was 2 negatives. So this is a -1, right? So that's kind of how you would find that. And then that's all you need. You can graph it because you know the center is 3, -1 right here. You know it's horizontal. So if it's horizontal, then the major axis is horizontal. So then you use your A, which is 4. So 1, 2, 3, 4. So you know that's 4 and 4. And again, you have to know that it's horizontal because you have to be having your major axis on the horizontal side. You know your B is 3. So 1, 2, 3. And then you can draw your ellipse. Okay. That's how you draw an ellipse, and you can double check that if you wanted by graphing the calculator. But that is an ellipse. That's the equation, the A to B, kind of some of the key features of them. So why don't y'all try the last two just to make sure you feel confident by yourself before we do practice, and then we'll call it a day for today. All right. So a little bit shorter lesson. So y'all try those two, and then I'll talk about what the practice is. I'll give you some time to do that. Okay.
Yeah, for the center, I put negative 4,6. And then it's vertical. And then the A should be 4, and then the B is 2.
Okay. Awesome. Y'all agree with that?
Yes.
Okay. Awesome. And let me see who else said they were done. Kevin, can you walk us through this one?
Yeah. So I put the co-vertices first, and then it said it had a major axis of 10. So the center's at 3, negative 3.
Mm-hmm.
And then I went 5 up and 5 down. And then I drew it. Yeah, and I got a center of 3, negative 3, a of 5, and a B of 1. And then the equation was x minus 3 squared over 1 plus y plus 3 squared over 25 equals 1.
Okay, very good. And you put the A under the Y because it was vertical, right?
Yes.
All right, awesome. So that's ellipses part 1. Thank y'all. That is kind of the key features as well as how to write the equation from just the basic information. Next class we'll talk about. Let me show you. We'll talk about these. What is the relationship between A, B, and C? We talk about A and B, but not C. So we'll talk about what C is. Okay. So that is part 2 of ellipses. Tomorrow, your practice is again IXL. It's an easy one. P.7. Find the properties of ellipses. So that one is in the pre-cal. Pre-cal P.7, again, that's due on Friday at 4:20. That's just like, it just asks you what's the A, what's the B, and kind of just the features based on the graph or based on the equations. Okay, so that's your practice. Let's do in the Zoom chat, if you can write 1 through 10, your level of confidence in understanding this material so far based on the lesson and how confident you feel about doing the practice. So 1 being you don't understand it all, 10 being you're good, 100%. Okay. Any questions? Any last minute questions?